Greetings everyone, my name is Solution and I'm honored to present our research entitled Combat Drone Swarm System based on Solana blockchain technology. My colleague Ivana Pirsky and I from the Louis Polytechnic National University have collaborated on this project. Our study explores how blockchain technology can revolutionize the operational security and efficiency of drone swarm, particularly in sensitive applications like counterterrorism and disaster relief. In the rapidly evolving field of unmanned aerial vehicles, drone swarms represent the next frontier in complex autonomous operations. Despite their potential, the deployment of drone swarms raises significant security concerns. Traditional communication and control systems expose these swarms to risks such as data interception and malicious attacks, potentially resulting in catastrophic failures. Recognizing these vulnerabilities, our research proposes a robust solution to shield drone swarm against cyber threats and enhance their operational reliability in hostile environments. Our thorough review of existing literature identifies several attempts to secure drone communications and operations. Prior studies have explored the use of encrypted communication channels and authenticated command protocols to safeguard data and commands exchanged within drone swarms. For instance, research has demonstrated the potential of blockchain technology in achieving tamper-resistant data lodging and command execution. However, these solutions typically focus on enhancing individual drone security and often neglect the systematic architectural needs of a fully integrated swarm, particularly under the conditions of dynamic real-time operations across extensive networks. To further illustrate, let us compare existing solutions. Traditional drone operation systems rely on centralized models that suffers from inherent weakness, including sus- susceptibility to single points of failure and scalability issues in managing large swarms. These systems, while somewhat effective in control scenarios, fail to offer the requisite security and flexibility needed for operations involving large, decentralized swarms. On the other hand, blockchain technologies such as those used in public and private chains offer promising alternatives. However, their real-time application in drone swarms is still nascent, with many studies not fully addressing the complex interplay between high throughput, low latency, and decentralized consensus required for operational viability. Our contribution to this field is the development of the UR SwarmNet, a model that integrates the high-performance Solana blockchain into drone swarm operations. This model not only enhances security but also ensures a high degree of autonomy and decentralized decision-making. By employing a blockchain framework, we can tell that each drone acts as an independent agent capable of making secure, real-time decisions without the need for centralized control. This dramatically reduces the system's vulnerability to attacks and failures, while enhancing operational flexibility and scalability. In the UR-SwarmNet model, the network structure is meticulously designed to support robust interactions among drones. Utilizing the Solana blockchain, known for its high transaction throughput and low latency consensus mechanism, allows our system to manage thousands of transactions per second. This capability is crucial for maintaining real-time communication within the swarm. Each drone is equipped with blockchain nodes, forming a peer-to-peer network that collectively make decisions and validates transactions, ensuring a secure and efficient operational process. Your SwarmNet is built on the blockchain using the network Solana. Its basic network structure is shown in the figure on this slide. Organization R1 is composed of multiple ground control centers from different theaters and assumes the responsibility of the network administrator. The initial structure of the network is determined by the network configuration NC1 pre-established by organization R1 and is started and managed by the administrator of R1. The small drone cluster participates in the network as an organization. To identify the identity of the organization members, this certificate is assigned to organization administrators and other network nodes and matches the certificate with the organization of the Solana blockchain network, effectively preventing illegal access to the UR Swarm network from the outside world. Let's delve into the transaction process within UR Swarm net. Every transaction, from data sharing to mission critical command execution, is recorded on the blockchain, ensuring integrity and traceability. This process begins with each drone collecting and encrypting data, which is then sent as transactions to be validated by consensus among all participating drones. The blockchain immutable ledger ensures that once an entry is made, it cannot be altered or deleted, thereby preventing any form of data tampering and ensuring that every piece of information is verifiable and secure. So the model security analysis that we made. First of all, your SwarmNet provides a good guarantee for the confidentiality of data. Your SwarmNet sets network access restriction based on the public key infrastructure, only issued by a specific organization CA that can be obtained. Only users with certificate can obtain access to the channel through the verification of the MSP component, which lays a good foundation for the communication environment of the drone. In addition, EOS-Formnet uses the TLS transport layer for secure communication between communication nodes through two-way verification, ensuring the identity of both communicating parties and establishing a two-way encrypted channel. Secondly, the immutability and multiple copies of the blockchain ledger ensure the integrity of the data, enabling the UF systems to resist improper modification and destruction of data by the outside world. Each main UF and ground control center in UF SwarmNet are deployed with an intelligence ledger of the channel to which it belongs, even if a master drone is hacked. The data can be restored by downloading the ledgers of other nodes. And finally, the decentralized nature of the UAV SwarmNet network ensures the availability of the UAV system, allowing the UAV to access the data information timely and reliably. As long as the most nodes in the network do not encounter hacker attacks, the normal operation of the entire system can be ensured. In addition, the US SwarmNet network also has high scalability. By modifying the network configuration and adding channels, the establishment of small UF cluster and the formation of a large UF cluster can be flexibly realized. The use of endorsement strategies can meet different levels of security requirements in actual combat missions. Advantages and challenges of this system. So the system, leveraging Solana blockchain technology, introduces several groundbreaking advantages over traditional UF management models. Primarily, the integration of blockchain ensures a decentralized, tamper-proof system that enhances data integrity, confidentiality, and availability. This decentralized approach mitigates the risk associated with centralized control, where a single point of failure could compromise the entire operation. Moreover, the Solana blockchain's capability for high transaction throughput and low latency underpins a responsive and scalable system capable of handling dynamic, complex swarm operations without sacrificing operational tempo or security. So, in conclusion, we've defined the UL Swarm network structure based on the private chain Solana, explored the method of integrating blockchain technology with drones, and established a complete security protection solution for the collaborative operation of drone clusters. Blockchain technology is playing an important role while the UAV system improves robustness, security, and scalability. It also has many limitations. For example, the main UF needs to maintain chain codes and ledgers, which will occupy a lot of memory. The main UF is responsible for decision making, endorsement, and controlling multiple tasks, such as submissive drones will have an impact on its combat performance. Ground control centers has weak control rights over submissive drones and cannot convey command promptly. In the future research, we'll explore the integration of artificial intelligence to automate decision-making process within the UF SmartNet, potentially reducing human oversight requirements and enhancing response times. Additionally, advancements in quantum-resistant cryptography are identified as crucial to safeguarding against evolving cyber threats. Thank you for your attention.